this what the one of the tasks. One of the tasks is classifying whether emails are spam or not. Then the experience is going to be watching us level the emails are spam or not. So when we are manually leveling an email as a spam or not, that actually is going to serve as an experience to that email program. So then after watching us level the emails, the number of the number of emails which will be correctly classified as a spam or not spam is going to be the performance measure. So by learning, they are going to learn by seeing how we are leveling the emails as a spam or not. Then they are going to perform the tasks of classifying the emails as a spam or not, and the number of emails which has been classified correctly. If the number of classification or the accuracy of the classification increases, then we can say that the machine has learned, then the program has learned the task T by the experience E. So this is what we mean by learning. Let's move to the various categories of machine learning. We are all aware about the various categories. I'll just give a brief introduction to all the categories. The machine learning algorithms are basically divided or classified in 4 categories. The first one is supervised learning, then unsupervised learning, semi-supervised learning, and reinforcement learning. So the supervised learning involves training the model on the level data, and it uses the trained model to make the predictions on the new data. It also involves the splitting any learning mechanism. It is going to involve the splitting of the data into 2 sets. One is the training set, and another one is the testing set. So the model is trained on the training set. Then afterwards, the performance is tested on the testing set. So the supervised learning, for the basic examples of supervised learning can be classification problem or regression problem. The difference is that in the classification problem, the level value is a discrete value, and the algorithms in classification or the supervised classifications are used to classify to which class or category the problem belongs to. But in case of supervised regression learning, the models are used to predict the outcome based on some continuous data. In unsupervised learning, the unsupervised learning is going to study how the systems can infer a function to describe a hidden structure from unleveled data. Here, it is also going to involve a training of data, except for the fact that the level value or the target value is not known in terms of unsupervised learning. So in this, the machine will try to cluster the similar type of data, or it will try to find a hidden pattern. So rather than making a prediction like supervised learning or classification, rather than making a prediction, the main aim of unsupervised learning is to discover the patterns. The performance of the models in the unsupervised learning cannot be evaluated. However, the performance of the model in supervised learning can be evaluated. There are various performance metrics to evaluate a supervised learning. However, the unsupervised learning it cannot be evaluated as the level value is absent or the level value is unknown here. As the supervised learning works on the level data and unsupervised learning works on unleveled data. So what happens here is that a lot of information is lost from the level data, which can actually be obtained from unleveled data. So in this case, the semi-supervised learning will come into action. The semi-supervised learning, as the name says, it is going to be a mixture of supervised and unsupervised learning, in which it is going to take both the unleveled and level data. So while taking the level and unleveled data, one thing should be kept in mind, that is the level data should be of shorter length as compared to the unlabeled data. That means the contribution of the labeled data is going to be more than the unlabeled data. And the basic idea behind semi-supervised learning is that there is a considerable change in the performance when both level and unlabeled data is used in conjunction. The training set use will be of shorter length because we are going to depend more on the level data, and we are going to consider lesser, shorter length of level data. The semi-supervised learning is normally used to detect the outliers in clustering. And the last category is reinforced learning or reinforcement learning. The reinforcement learning works by developing systems in which it improves which improves the performance by taking the feedback from the environment and taking possible steps to improve them. It is an act of learning from the environment by interacting it with without any help from the humans. It is going to be an iterative process. The process is going to be repeated again and again. It depends on it's kind of a feedback system. Depending on the feedback, depending on the interaction from the environment, it is going to make the changes. Let us see graphically now. The figure 1 source or the figure 1 depicts the framework for a supervised learning. We can see that in this framework itself, we are providing input and the levels to the machine learning algorithm. And the input may be textual data, it may be document, it may be images, it may be audio, it may be video, which is going to be a combination of image and audio. So once we are giving an input data, the features will be extracted. There is a condition here, the features will be extracted if it is a traditional machine learning algorithm, because in a traditional machine learning algorithms, the features needs to be manually extracted. However, if we are going for advanced learning techniques like deep learning method, then the feature extraction will be skipped, because the deep learning method automatically extracts the features. So we do not need to extract the features manually in terms of deep learning. So we are giving both the input and the output level to the machine learning algorithm for during the training phase, and during the testing phase, we will be providing a new data. If the training is based on text, we'll be providing a text data for testing. Then the same method will be used for extracting a feature vector, and the features will be tested using the predictive model, which we have already trained using our input level and output level. And finally, the output is going to be an expected level in terms of supervised learning. The main difference here from between the supervised and unsupervised learning here is going to be in terms of the input and the output. In terms of the input, we are going to give only the training data as an input, and there will not be any output level. We will be giving only the informations. So from those input data or the training data, the features vector will be extracted. Then we will be feeding it to the machine learning algorithm for training. And once a model is formed, we'll be giving a new data for testing. The features vector, similarly, the feature vector will be extracted, or the features will be extracted to form the feature vector. And then we will test it with the model. Here, the difference is in the previous figure, the output of a supervised learning is going to be a class level. We are already having expected level. However, in terms of unsupervised learning, the output may be a likelihood, or it may be a cluster ID, or it may be a better representation of the data. That means after extracting the hidden informations or the hidden pattern, we are going to give, or we are going to cluster the informations which are provided. Now let us come to the main topic here, the machine learning in healthcare. So we all know that machine learning has a huge plays a vital role in healthcare, not only in healthcare, but many other applications. And healthcare is one of the major issue now. And the reason why machine learning is particularly valuable in healthcare industry is that because it can help us make sense of the massive amounts of healthcare data that is generated every day within the electronic health record. Because using machine learning, we can actually find the patterns and insights that will be very much tedious for us, or that would be impossible to find manually. So the main motive behind machine learning in healthcare is to find the patterns or the insights from the massive amount of data. Not only in finding the hidden patterns, it can also help in reducing the cost, and at the same time, it will also help in improving the care. Let us see one by one all the applications. While new machine learning applications are emerging from time to time, machine learning can be used in power system, machine learning can be used in manufacturing, machine learning can be used in electrical. So there are various applications of machine learnings, but the most common application of machine learning is centered in healthcare. That is to improve the quality of the care and the patient health outcome. So one of the application is prognosis. Let us see what is a prognosis. A prognosis is the process of predicting the expected development of a disease in a clinical practice. It is also going to include identification of the symptoms and the signs related to a specific disease, and whether the patient will become worse, or it will improve or remain stable over a time, or identification of any potential associated health problems, complications, or the likelihood of survival. For example, we have various machine learning models that has been recently developed for identification and classification of different types of cancers. It may be brain cancer, it may be lung cancer. So various kinds of models have been already developed. This is one of the application of machine learning in healthcare section. It also helps in diagnosis of disease. Let us see how it can help in diagnosis. First of all, it helps us in maintaining the electronic health records. Hospitals and other healthcare services are actually producing a large collection of electronic health records on a daily basis. And these informations or these records are actually a mixture of structured and unstructured data. So, and this information actually gives us a complete medication history of a patient. So for each patient, we are going to have a large number of data, which is going to include both structured and unstructured data. And machine learning algorithms or models have been used for extraction of clinical features for facilitating the diagnosis process. For example, we can have a semi-supervised approach for extraction of diagnosis information from unstructured electronic health records. The machine learning can be used for diagnosis of diabetes from electronic health records. So like this, we can actually exploit the, or we can say we can actually take the advantages of massive amount of information which is available in electronic health record. It can also be applied for medical image analysis. In medical image analysis, machine learning techniques can be used for efficient and effective extraction of information from medical images that are actually acquired using different imaging modalities. We have different medical, we have different imaging modalities like MRI, CT scan, X-ray, ultrasound, then positron emission tomography, which we call as PET scan. So this modalities actually provides information, quite important functions and informations about different body organs, and it is going to play a very crucial role in the detection or any diagnosis of any abnormalities which are found in the human body. So the key purpose of medical image analysis is to assist the clinicians and radiologists for efficient diagnosis and prognosis of the disease. The prominent tasks in medical image analysis is going to be detection. We can have a detection of a tumor, we can define it, we can detect it, or we can classify it as malign or non-malign. We can use it for classification, we can use it for segmentation, retrieval, reconstruction, and image registration. We can even use the machine learning techniques for enhancement. Why do we require an enhancement of a medical image? Let me give a quick uh, insight to the enhancement, because the medical images, most of the time the medical images may be in the form of degraded. If the medical images are degraded, then what will happen? It will directly affect the diagnosis of the process. So enhancement of the degraded medical image is an important pre-processing step that is going to directly impact the diagnosis. And from where the degradation comes into the picture is that there are many sources of noise and disturbance encountered in the medical image acquisition process. That means while capturing the medical images, there are going to be noise and disturbances, which is actually going to degrade the quality, not only the quality, but the significance of the resultant image. For example, when we are taking an MRI image or when we are generating an MRI image, it is quite a lengthy process. It actually requires several minutes to produce a good quality image, and to acquire a detailed soft tissue contrast, the patients have to remain still and straight as much as possible. And if movements are there, then it is going to cause some false artifacts in the image acquisition. So while capturing the image, if the patients move, then there are going to be false artifacts. So the complete process has to be repeated multiple times to produce a significantly useful image. So also it also depends on the body area being scanned and the number of images to be taken. Sometimes the patient might have to hold their breath during the short scans. Therefore, any movement of the subject can introduce artifacts in the acquired image. So whenever there is an artifact, whenever there is a noise in the image, the medical images are further needs to be enhanced. This is one of the research topic where we can focus on for the time being. And machine learning models like convolutional denoising and autoencoders are already developed for denoising the medical images. And next is detection. The detection, as I just said, the process of identifying the specific disease pattern or the abnormalities in medical images is known as the detection. So it can be used to detect whether there is any tumor or not. If the tumor is there, whether it is malign or not, it can be detected perfectly with the help of machine learning techniques. In traditional clinical practice, what we follow in traditional way is that these abnormalities are actually identified by expert radiologists or physicians, and it often requires a lot of time and effort. So in order to lessen the burden of the radiologist and physician, and at the same time to get the result in a shorter period of time, the classification DL models have been developed to detect the abnormalities, and it has already proven to give high performance in medical image classifications. And another important aspect of machine learning in medical image analysis is reconstruction. The reconstruction is actually the process of generating interpretable images from the raw data, which are being acquired from imaging sensors. So the fundamental problem in image reconstruction is that it inherently slows the data acquisition process. And many of the time, many
Madam, Dr. Neelima ma'am. Ma'am, please continue.
Is it fine now?
Little, we could hear you. Please raise your voice a little.
Am I audible now?
Yes, ma'am.
Okay.
Okay, please continue.
So it was stop in between.
Ha, ma'am, technical issue. Sorry.
Okay. So I'll continue with the real-time health monitoring application of machine learning in real-time health monitoring. So the real-time monitoring of a critical patient is actually crucial and is a key component of the treatment process. We actually need to continuously monitor the critical patients, or maybe a patients with autism or all age patients. So how machine learning can help in monitoring the real-time health monitoring of patient is that the continuous health monitoring wearable devices, like we already have wearable devices, IoT sensors and smartphones, which can be actually used for continuous health monitoring. So in a typical setting of continuous health monitoring, this health data is actually collected using a wearable device and smartphone, and then transmitted to the cloud for analysis using machine learning or deep learning technique. Then the outcome of the analysis are transmitted back to the device for appropriate action, or for necessary actions. Then next is visualization of the biomedical data. We can actually use the machine learning techniques to create 3D visualization of biomedical data such as RNA sequence, protein structure, and genomic profiles. We can use it not only for visualization of the medical images like CT scan or MRI scan or chest X-ray images, but it can actually be used to create 3D visualization of biomedical data. It also helps, machine learning also helps in improving diagnosis and disease identification. It actually helps in identifying previously unrecognizable symptoms pattern and compare them with larger data sets that will help us in diagnosing the disease earlier than their development. So machine learning in healthcare can actually be used to develop better diagnostic tools to analyze the medical images. For example, a machine learning algorithm can be used in medical imaging using pattern recognition to look for patterns that indicate a particular disease. So this could actually help the doctors in making quicker and more accurate diagnosis. It also helps in keeping the patient record updated, accurate, and easy to transfer between clinics, physicians, and medical staff. We can also use the machine learning to analyze multimodal data and make patient-tailored decision based on all the possible treatment options. We can even have a personalized treatment option with the help of machine learning techniques. We can use the machine learning to enhance the selection of participants for clinical trials, data collection procedures, and analysis of the results. Lastly, we can use machine learning to identify the potential pathways for new medicines and develop innovative drugs to treat various medical conditions. A deep learning model can actually be used to identify relevant information in data that could actually lead to drug discovery, the, the development of new drugs and new treatments for diseases. For example, a machine learning can actually be used to analyze data from clinical trials to find the previously unknown side effects of drugs. This will actually help in improving the patient care, the safety and effectiveness of the medical procedures also. So these are some of the applications of machine learning in healthcare. So the scope is still there for further research. So we can actually work in any of the applications for machine learning in healthcare. But once we have decided the area on which we would like to work on, we need to decide on the type of the healthcare data which is available to us. So let us see which are the various types of data that are available in terms of healthcare. The first one is clinical data. Clinical data are the data which are actually collected during the ongoing treatment of the patient, including the electronic health record. It will comprise of laboratory tests, radiological image, and any allergies or any other information which has been recorded. Then the next one is sensor data. We can also work on sensor data. The data elements produced by sensor, including the time series signals, is actually a sensor data. This time series signal is actually an ordered sequence of here. So this data, since we cannot directly use the time series signals, these data elements are actually processed by computing devices, and it is represented as a simple numerical or categorical value, and it can be directly used for analysis. The third one is omics data. Omics data is a collection of data. It consists of both complex and high dimensional data. It can consist of genomic, transcriptomic, and proteomics. So it's going to be a mixture of genomic. It may be or it may not compose of all the three, but it is going to be a mixture of genomic, transcriptomic, and proteomics data. So handling this kind of data, handling omics data actually requires various techniques, and machine learning algorithm is one of the techniques to handle omics data. Then we have genomic data. Genomic data is actually a collection of gene expression, copy number variation, sequence number, and DNA data. And they are mainly genomic data are actually mainly used in bioinformatics. The genomic data will give us the information related to genes. Then we have transcriptomic data. In transcriptomic data, we are going to have a collection of multiple mRNA transcript data. These samples can be analyzed and can be extracted to generate different data sets. We can actually extract informations from transcriptomic data. That means from mRNA transcript, we can actually extract different data set. Then the last one is proteomic data. Proteomic data is a collection of protein expressions in the form of cell, tissue, or an organism. It is actually a representation of the actual functional molecules in the cell. So machine learning can also be used to analyze the proteomic data. So these are the various healthcare data which are available to us. And the challenges associated with the healthcare data is the first and foremost challenge which are associated with healthcare is safety challenge. When we are developing a model in developing a model for a healthcare data or a healthcare industry, what happens is that whatever we are developing, we are running it in controlled lab environment. So the performance of those machine learning algorithms are excellent in controlled lab environment, and safety of machine learning and deep learning is going to determine how safe the machine learning system is for the patients. Because when we are actually applying our model in real life, it may not be the same situation like our lab environment. Second one is a privacy challenge. Privacy is also one of the major challenges in any of the data-driven healthcare, because it is concerned with the user's data. The user will expect that their healthcare service provider will be following some necessary safety measures to safeguard their rights to the privacy of their confidential information. So necessary attention should be paid to understand the privacy concern at each stage of data processing and transfer of data among the different departments within the hospital. The privacy challenges not arises not only for the patient information user data, but it also arises with adoption of machine learning or deep learning technique for building the biometric healthcare system. So when we are having a system for authentication of, like, we can have a use of biometrics for authentication of medical IoT devices, or any equipment, for authentication of any equipment or any online system. So the privacy has to be kept in mind while developing the model. The third one is the ethical challenge. In user-centric application of machine learning, it is actually important to ensure the ethical use of the data. So the explicit measures should be taken to understand the targeted user population and their sociological aspect before collecting the data for building the machine learning model. If ethical concerns are not taken into the account, then what may happen is that the application of machine learning in realistic setting will have an adverse effect. Then there is also a problem with availability of the good quality data. The availability of diverse and high quality data is one of the major challenges in healthcare. For instance, the amount of data available to the research community is very small in size and limited in scope, even though there are massive amount of information, massive amount of patient data has been generated on a daily basis by the healthcare service provider. But the amount of data available to the research community is very, very small in size compared to the available data, and it is also limited in scope as compared to the heterogeneous collection of large-scale multimodal patient data, which is being generated on daily basis by different small and large-size healthcare institutions. However, the development of good quality data that is going to resemble the clinical setting is very much challenging and requires the resources for management and maintenance. The availability of high quality data can actually effectively serve the intended purpose of disease prediction and decision making for planning the treatment. So the data collected in practice may suffer from different issues like redundancy and biasness may be there. As the machine learning models performs inferences by solely learning from the data on which they are trained, so therefore the effect of the data generated by undesirable past practices of the hospital will be reflected in the outcome of the algorithm. So there is a need for a good quality data in order to have a very good outcome of our machine learning model. Next is lack of data standardization and exchange. This is also a major issue or major challenge being faced now, since medical machine learning or deep learning systems, it actually helps us in understanding the underlying healthcare tasks, which can actually be achieved by utilizing the patient's data. For example, when we are using a patient data, radiology, what we are going to do is that it is not only about the clinical imaging. Suppose the patients, not only the patient's radiological images or medical imagings are required, but we also require other information, other data to derive the precise conclusion for an imaging study. We also require many other informations in addition to the imaging. So this actually calls for integration or data exchange between the healthcare system, because the electronic health record, some of the records will be held by some other section, and the then the imaging modalities, the departments will be holding another kind of information. So this information actually needs to be integrated, and the data exchange should be there between the healthcare systems. So, despite the extensive research on the data exchange standard for healthcare, there is still a huge ignorance in in following the standards in healthcare IT systems, which is actually going to affect the quality and efficacy of the healthcare data. So, since the data are not integrated properly, so the result which we are going to get from that particular analysis may not be accurate. So the data integration to match the diverse patients' medical record is actually very crucial to deliver a high value patient care. So the lack of appetite, let's say the lack of appetite to implement the data exchange standard in wider healthcare, it actually hinders the efficacy, or let's say it hinders the efficiency of the machine learning systems. Then we have a distribution shift. Let us see what is a distribution shift. The problem of data distribution shift is actually another major challenge. In clinical practice, training and testing data distribution can diverge due to many reasons. So medical data is generated by different institutions or different hospitals using different devices for patient having complicated disease. So due to this issue, the machine learning models developed using the available public database may not give the expected performance when it is actually deployed in actual clinical environment. So when we are training our model, we are actually training our model on the available public data set. But when we are testing it, when we are running it, or when we are deploying it in an actual clinical environment, it may not be giving us the expected performance. This is a most challenging problems that is yet to be solved. Uh, one of the example of the distribution shift problem is that uh, when we are training and testing the data set in our lab environment, one of the foremost and strong assumption is that both the training and test data sets are derived from a similar domain. However, in real life, this assumption is not valid in practice, and the model which are being trained under such assumptions, it will actually fail to generalize the other domains. The data from the healthcare is actually ambiguous, noisy, and incomplete. And at the same time, the clinicians or the radiologists or the physicians are actually slow in adapting to the technological changes and its applicability in healthcare. This also needs to be improved. So these are some of the open challenges for machine learning in healthcare industry. Let us see one of the case study here. This is one of the research work which is being carried out at NIT Nagaland. So what we are doing is we are actually classifying the COVID-19 disease using the chest X-ray images. As we all know that during the COVID-19 crisis, due to the dense population of our country, there was inadequacy of testing kit. So when we were having lesser number of testing kits, when we were having the problem with inadequacy, the radiological imaging could have actually helped in diagnosing the disease or in detecting the disease, and it would have helped us in necessary treatment in the due time. So this is just a simple example here. Some sample images of a chest X-ray images. The figure 4A. Figure 4A gives the chest X-ray images of a normal person. Figure 4B gives the chest X-ray images of a person infected with pneumonia. And figure C gives the images of a person infected with COVID-19. So we can see, we can actually see the difference in the chest X-ray images. But how a machine is going to classify, or how a machine is going to detect which of the patients are infected with pneumonia, which of the patients are infected with COVID-19, and which of the patients are normal, are not infected either with pneumonia or COVID-19, is one of the issue which is being considered. So according to the, if we're going for a supervised machine learning, since it is going to be a classification, as the figure number images, the chest X-ray images, and then we will be extracting the features if we are going for traditional machine learning. So when we are extracting the information, since the chest X-ray images are basically a grayscale images, so we will be extracting the images extraction of color features. So instead of color features, we can actually go with shape and texture. Mainly texture. It can be a combination of shape plus texture, or we can only have a texture also. So we can actually find out the pattern. We can try to extract the features so that we will be able to find out the hidden pattern or the knowledge from those features. And those features can actually go for optimization, or let's say dimensional reduction, depending on the features which we are going to extract. And it will go as an input to the machine learning algorithm. If we are going for traditional machine learning algorithm like SVM, KNN, decision tree. And if we are going for a deep learning model like CNN, then directly we can give the input. But there is an issue with deep learning for deep learning in healthcare, or deep learning for classification of classification of COVID-19 disease using chest X-ray images. We will get to know soon what is the issue with deep learning. So once we have trained the model, what we are going to do, we can have our test images, we can feed it to the model, we can extract the features, we can feed it to the model, and the model can classify whether the person is infected with pneumonia or whether the person is infected with COVID-19. And in classification, we can have multiple or multi-level classification also. A person may be infected with multiple disease. For example, a person which is infected with pneumonia may also be infected with COVID-19. So depending on the classification algorithm which we are going to use, it will be able to identify it. The accuracy of any of the model actually depends on the availability of the data. And in case of COVID-19, it actually becomes a major concern because the accuracy of the model which we are getting is actually questionable due to the use of insufficient data. The symptoms, the second issue with this classification is that the symptoms of pneumonia and COVID-19 are actually very much similar. So there is still a need for identification of appropriate technique to detect COVID-19 with optimum accuracy. And the third one is imbalanced data set. We have the data set which are available to us for detection of COVID-19 is actually imbalanced. We are having more number of images related to a normal patient, and the amount of information available for chest X-ray for a person with COVID-19 is very much less as compared to the chest X-ray images of normal patient. This is one way how we are using machine learning for detection of classification of COVID-19 or detection of COVID-19 using the chest X-ray images. Now, let us come to the point in deep learning, because before concluding, I would like to touch the deep learning since we are going with the basic machine learning concepts. As we all know, deep learning is also a subfield of machine learning, and it is actually inspired by structure and function of the brain, and it is actually, let us say, it can be called as an advanced version of artificial neural network. So Deep learning, we consider it as a modern or advanced version of machine learning that uses the concept of neural network in order to solve more complex problems, which actually requires high dimensional data and automated features. So now the question arises is why deep learning? Why do we require a deep learning? This is this is the graph showing the showing the performance of a model with respect to the amount of data. We can see that in traditional machine learning algorithms like SVM, decision tree, or random forest, as the amount of data increases, the performance increases, but after a certain period of time, the performance of the model gets saturated. And this is for the small neural network. It also increases, the performance also increases, but after a certain period of time, it again becomes saturated. Then we have medium neural network. That means we have a lesser number of hidden layers. Sorry, in small neural network, we are going to have lesser number of hidden layers. And in medium neural network, we are going to have larger number of hidden layers. So even for both small and medium neural network, the performance increases as the amount of data increases, but it becomes saturated after certain period of time. And this is for large neural network, or let's say this is for a deep learning network like CNN or RNN. So as the amount of data increases, the performance keep on increasing. So what deep learning does is that it exploits or it takes the advantages of massive amount of data. So nowadays we are seeing that there is a trend for many of the researchers, any of the application which any of the application, any of the solution, any of the problem which we are facing, we directly go with deep learning because it has got a higher accuracy value, or we assume that deep learning will give us better performance. But the issue here is that deep learning is actually mainly developed for huge amount of data to exploit the quantity of the data. There are actually many challenges and drawbacks associated with deep learning, even though there is a lot of progress which are already made in healthcare. So one of the major important factors for deep learning is amount of data. And many of the network parameters which are needed for a neural network, because since deep learning is based on a neural network, actually to achieve this, a lot of data is needed. And usually for any neural network, the number of parameters needed should be 10 times more than the number of samples. And at the same time, understanding the variability of the disease for each individual is also more complicated. Deep learning has been already used for various conditions or various diseases like Alzheimer, dementia, diabetic retinopathy, and brain hemorrhage, etc. So the problem here with using deep learning for COVID-19 or using deep learning for healthcare data is availability of the data. There are relatively small number of COVID-19 chest X-ray which are currently available. So even though deep learning does not require manual extraction of the features, deep learning actually extracts the features automatically. We do not need to manually extract the features. So it may seem easier for us. We may say that we are getting 100% accuracy, even 100% accuracy for COVID-19 disease detection, but there is actually a case of overfitting because we have a very relatively small amount of or small number of data available with us. So using a deep learning is not going to be a practical solution for us. However, we can, if we want to go for deep learning in healthcare data, we can actually enhance it by using a transfer learning or data augmentation. And what the idea of transfer learning is that we are going to the idea of transfer learning is that we are going to utilize the information gained from one problem A and then apply it to another problem B. For example, uh, using the knowledge of how apples are detected, is we are actually going to learn how to detect a mango. That is actually a transfer learning. For example, we can have for a tiger, we can have a knowledge how to detect a tiger, but we may not have sufficient information to check how to detect a cat. So we are going to use the knowledge which we have learned from how to detect a tiger and apply it to how to detect a cat. This is the basic concept of transfer learning. And second one is data augmentation, which doesn't seem much feasible. That is, we can actually create multiple copy of the images, which can be generally rotated by, which can be actually generated by rotating the image. We can rotate it by 5%, 10%, 20%, like that, or we can randomly zoom some of the image, or we can randomly shift the images horizontally, or we can randomly shift the images vertically or flip the images. So what we are basically doing in data augmentation is that we are creating the data. We are actually going to create duplicate data from the original data. And how we can do it? We can compress it, we can rotate it, we can flip it, or we can shift the image, or we can zoom it. So this is basically going to be the same kind of images which we are going to make it for, which are going to use it for training purpose. So this data augmentation is used whenever we have lesser number of data for deep learning. But this does not seem much feasible, because anyway, the information which we are going to extract is going to be the same kind of information. So these are the limitations associated with deep learning. Sorry, I do not have much details on deep learning, but we all know that deep learning means more layer or more level. But can we say that only increasing the number of layer is going to be deep learning? Because in ANN, because there is no exact definition of how many number of layers is going to be considered as deep. Like, what is going to be the number of layers in ANN so that we can consider it as deep learning? Actually, deep learning is not only about the number of layers, but it is also about the hierarchy of the information which we are going to extract. We start with extracting the information because even though in deep learning, when we are using CNN or RNN, we are just giving the image as an input, and then we are getting the features, and then we are putting it for classification purpose. But for example, in CNN, we are having a convolution layer, first layer of convolution, second layer of convolution, third layer of convolution. So increasing the number of convolution layer doesn't mean that it is a deep learning. What we are doing here is that in the first layer of uh, convolution, we are trying to extract the low-level features. So from the low-level features, if we are going for a second level of convolution, we are actually extracting the middle level of features. Then we are going with high-level features. When we say low level of features, the color intensity value may be low level of information. From those color intensity, we are actually trying to generate the histogram. The histogram of those intensity may be a mid-level, let us say. From the histogram, we are trying to extract the shape, or we are going to go with let's say color distribution of that particular images, and then, or we can go with the object detection. or we can go with the shape of the object, texture of the object. So like this, when we are increasing the amount of the information which when we are actually increasing the level of the information which we are extracting, this actually comes as deep learning. Deep learning is not only about increasing the number of layers, it is actually about the extraction of the information. If we are extracting the information in hierarchy, then we can say that it is a deep learning techniques. So with this, I would like to conclude my presentation. And this is my email ID and contact number. If you have any, if you require anything related to research or any collaboration, you can email me in this number, or you can email me, or you can contact me in this number.
Hello. Thank you so much, ma'am. Session was truly informative. Neelima, ma'am.
Yes, ma'am.
Thank you. Thank you. Such a beautiful session you have conducted. Thanks for the information. Thank you. Any queries from the participants? Through the chat box, you can reply. Madam would try to solve. No queries? Okay. Thank you so much, ma'am.
Thank you. So I can leave the meeting?
Yeah, you can, ma'am. You can. Participants, see you all tomorrow at 10 p.m. sharp.